All right, let's get this deep dive started. This time, we're heading back to science class. But you can relax, no tests or anything like that. We're tackling those series circuits everyone's heard of. And we've got this really cool interactive physics simulation to help us out. It's all based on a JavaScript applet Getrit. Those circuits are in everything, by the way, from simple light bulbs to the most complex gadgets. So get ready, because we're about to make electricity come alive and hopefully have some aha moments along the way.
Yeah, it really is surprising how much you can learn from something like a simple JavaScript applet. We're going to go pretty deep today. Just by
Yeah.
messing around with these virtual switches and bulbs, I think you'll be surprised.
Definitely. So before we get too hands-on with the simulation itself, I think it'd be good to define what a series circuit is. I mean, we hear the term all the time, but what's the real deal?
Okay, so imagine, picture a single pathway, like a one-lane road, but for electricity to flow through. That's basically what a series circuit is. You've got different components all connected in a line, things like bulbs and switches, all hooked up to a power source. The key is that the electricity has to go through each component one by one to complete the whole loop.
So it's like a chain. If one link breaks, the whole thing is useless?
Exactly. And this simulation is perfect for visualizing that. You get to play around with switches virtually, opening and closing the circuit, and you see right away what happens to the bulbs.
That instant feedback must make such a difference. It's way better than just trying to imagine it in your head like I did back in school. I could have really used this simulation back then.
Oh, absolutely. And it's interesting to think that this whole series circuit thing wasn't always obvious. Like way back in the late 1800s, when electric lighting was brand new, inventors were trying all sorts of ways to connect those early light bulbs. Series circuits were a huge step forward. But, as we'll see, they do have some drawbacks.
Right, it wasn't all smooth sailing. Okay, so we've got the basics of series circuits down. Time to dive into the simulation and see how it all works in action. What kind of interactive elements make this applet so special?
Well, one of the coolest things is that you can really experiment. You have switches for opening and closing the circuit, a reset button to start fresh, and there's even this clever gray panel that throws you some mini challenges.
Ooh, that gray panel sounds intriguing. It's got to be more than just flicking switches on and off, right?
Right, so this panel throws some mini quizzes at you about the circuit. Like, it might ask you which bulb will be brighter depending on how the switches are set. It makes you really think.
So it's not just watching what happens. You have to predict and then test yourself to see if you understand it. But what happens if you get it wrong? Does the simulation just give you a big fat error message?
Nope, not at all. This is one of the best things about the simulation from a teaching point of view. If you get the answer wrong, it doesn't just say try again. It actually tells you why you were wrong, which helps you learn from those mistakes in a safe environment.
That's so important for building confidence and encouraging people to try things out, especially with something like physics, which can seem intimidating. It's not about being right or wrong. It's about understanding why things happen the way they do.
I completely agree. And to make it even more fun, when you get an answer right, the simulation closes the switch in the circuit for you. You actually get to see your prediction come true. It's a real aha moment.
Literally making the light bulb light up
Yeah.
is the perfect metaphor.
Right.
This active, hands-on approach is so much better than just reading a textbook or watching a video. You're really engaged with the material, not just passively absorbing it. This whole thing makes me think about those old Christmas lights, where if one bulb went out, the whole string went dark. Always a pain. But looking back, that's a perfect real-world example of a series circuit in action.
Oh, for sure. Those old Christmas lights were nothing but trouble.
It's funny how those little everyday annoyances can be physics lessons in disguise.
Absolutely.
We've all been there, wrestling with a string of lights, wondering why they decided to die on us.
It's true. It's those relatable moments that make learning about circuits fun and engaging. You know, the series circuit, as simple as it is, it's not the only way to connect things electrically. There are also parallel circuits where each component has its own separate path. Think of it like having multiple lanes on a highway instead of just one.
That makes me wonder, are there advantages or disadvantages to using series versus parallel circuits? Like, why wouldn't you always choose the multi-lane option?
That's a great question. It depends on what you're trying to achieve. Series circuits are easy to design and don't need as much wiring. They're perfect for simple things like those basic light strings, or for circuits where you want one switch to control everything. But they do have their limits. If one component fails, like a bulb burns out, the whole circuit breaks down.
Yeah, right back to those Christmas lights. It's all or nothing. So with a parallel circuit, if one bulb goes out, The others stay on because they each have their own path back to the power source.
Exactly. That's a big advantage of parallel circuits. They're more reliable and more flexible, like the wiring in your house. It's a complex web of parallel circuits so that if one light bulb burns out, your whole house doesn't plunge into darkness.
Makes sense. It's good that we use different types of circuits for different purposes. Okay, let's get back to the series circuit simulation. We were talking about that challenge panel and how it asks you to predict things like bulb brightness. Is there something deeper going on there?
There is. It introduces a really important concept called voltage division. Might sound complicated, but it's pretty intuitive once you get the basic idea.
Okay, I'm all ears. Hit me with that voltage division knowledge.
Think of voltage as the pressure pushing the electricity through the circuit. In a series circuit, that pressure, the voltage, is shared between all the components, so each one gets a piece of the total voltage.
Like dividing up a pizza among a group of friends. The more friends you have, the smaller the slices.
Perfect analogy. And the simulation shows you this happening. Remember how the bulbs get dimmer when you add more of them in series? That's because the voltage is being split between more bulbs. So each bulb gets less voltage, which means less brightness.
Wow, that makes it so clear. So the applet isn't just showing us what's happening, it's teaching us the principle of voltage division without even realizing it. It's like having this extra layer of understanding.
Exactly. That's the beauty of a well-designed interactive tool. It guides you to a deeper level of understanding. Without you even noticing, you're learning something complex.
So we talked about how voltage gets split up in a series circuit. But I'm curious, what if you increased the total voltage at the source? Would that make all the bulbs brighter, even if they're still sharing the voltage?
Another great question. And this is an important point. Yes, increasing the source voltage would definitely make the bulbs brighter. It's like giving your friends a bigger pizza even though they're still sharing. Each slice is now bigger.
So the way the voltage is divided stays the same. But the total amount each bulb gets increases. You're basically scaling up the whole system.
You got it. And this principle is super important for understanding how circuits work, not just in theory, but in real-world applications too.
We've gone from troubleshooting Christmas lights to the electrical grid in just a few minutes.
That's the power of learning.
And speaking of real-world stuff,
Yeah.
it reminds me of this time I had to fix a lamp at home. It was a simple series circuit problem. One of the wires connected to the bulb socket had come loose, breaking the circuit. As soon as I reconnected it, the lamp worked like a charm.
Nice.
It's those everyday aha moments that really solidify these concepts. We go from abstract ideas to actually using that knowledge to solve problems.
It's so satisfying to see how it all comes together.
It really is.
And those small victories, like fixing a lamp or figuring out why those Christmas lights went out, they can make you want to learn even more about how things work.
For sure, it sparks that curiosity.
It's a great feeling. Yeah, it's amazing how fixing something simple can turn into a science project.
Right. This whole conversation about series circuits and simulations has got me thinking about how we learn in general.
I know what you mean. This applet shows just how powerful interactive learning tools can be. Not just for students, but for anyone who's curious about how things work. It makes complex stuff easy to understand. And even fun, dare I say it.
Definitely. It's like tapping into that inner kid who loves to tinker and explore and figure things out.
Exactly. And it's not just memorizing facts. It's about building that critical thinking muscle, being able to look at a problem, make a guess, and then test if you were right.
It's about becoming a problem solver, not just someone who takes in information passively. So for anyone listening who's been following along with us on this deep dive into series circuits, what would you say is the main takeaway? Why should they care about this stuff?
That's a good question. I think the most important thing is that understanding even basic circuits gives you a new way to see the world. All of a sudden, the technology around us becomes less mysterious and more understandable.
You get to peek behind the curtain and see how the magic happens.
Exactly. You realize it's not magic, it's logic. It's all based on principles that anyone can learn.
So next time you flip a light switch, or charge your phone, or turn on your computer, take a second to appreciate those little electrons flowing through those circuits, making it all possible. And maybe it'll spark your curiosity to learn even more, to dig a little deeper into the why behind the what.
I love that. And who knows? Maybe one of our listeners will be inspired to create the next generation of learning tools. We need more engaging and accessible ways to teach about science and tech, to get everyone excited about learning.
Now that's an inspiring thought. So to everyone listening, if you've got an idea for a cool physics simulation, don't be afraid to share it. You never know who you might inspire.
You never know.
And with that, we've reached the end of our deep dive into the fascinating world of series circuits. I hope you found it enlightening, and maybe even sparked a little bit of that curiosity to learn more.
Me too.
I know I did. Until next time, keep those brains buzzing and never stop exploring the wonders all around us.
You know what? It really is amazing how even fixing a simple thing like a lamp can turn into a science experiment.
It's true.
And it makes you appreciate the power of those everyday aha moments. It's like we go from these theoretical concepts to actually being able to use that knowledge in real life.
Yeah, it's a great feeling when it all clicks.
It is. This whole conversation we've been having about series circuits and these interactive simulations, it's got me thinking about the bigger picture of learning and education.
I know what you mean.
Like, this applet really shows the potential of these interactive learning tools. And not just for students. I mean, it's for anyone who's curious about the world around them, you know?
Absolutely.
It makes these complex topics so much more approachable. And even, dare I say, fun. Right. It's like we're tapping back into that childlike curiosity we all have, that desire to just tinker and explore and figure things out.
Yeah, exactly. And it's not just about memorizing facts and figures. It's about developing that critical thinking mindset, being able to analyze a problem, make a prediction, and then test it out.
Yeah.
So for everyone listening out there who's been with us on this deep dive into series circuits, what would you say is the most important takeaway? Why should they care about all of this?
That's a good question. I think the biggest thing is that understanding even basic circuits, it gives you this whole new perspective on the world, all the technology we're surrounded by. It suddenly becomes less mysterious and more understandable.
You get to pull back the curtain and see how it all works.
Right, and you realize it's not magic, it's logic, it's principles. And those principles can be learned and understood by anyone.
So the next time you turn on a light, or charge your phone, or boot up your computer, take a moment to appreciate those little electrons zipping through those circuits, making it all happen. And hey, maybe it'll even inspire you to dig a little deeper, to explore the why behind the what.
I love that.
And who knows, maybe someone listening will come up with the next amazing interactive learning tool.
That would be awesome.
Because we need more engaging and fun ways to teach people about science and tech.
We do.
And who knows, maybe even spark a lifelong passion for learning in someone.
Now, that's a great thought to end on.
It is, isn't it? So to everyone out there, if you've got an idea for a really cool physics simulation, don't keep it to yourself. Share it with the world. You never know who you might inspire.
That's right.
Well, folks, that wraps up our deep dive into the amazing world of series circuits. I hope you all learned something new.
Me too.
And maybe even had a little fun along the way.
Absolutely.
I know we did. Until next time, keep those minds curious and never stop exploring.
Still curious, everyone.